Kubernetes and GKE Part 30. This episode has 2 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain AKS. Here's a strong way to approach it. AKS, Azure Kubernetes Service, is a managed Kubernetes service provided by Microsoft Azure that simplifies deploying, managing, and scaling applications running in Kubernetes. Core idea: AKS lets you run Kubernetes on Azure without managing the control plane. Azure handles the cluster management, while you focus on applications. Why AKS is used: it removes the operational overhead of setting up Kubernetes control plane, maintaining it, managing master nodes, handling upgrades and patches, ensuring control plane high availability. What Azure manages in AKS: 1. Control plane. Fully managed. Azure manages Kuba App Server et Kuba Scheduler, Kuba Controller Manager, checkmark, highly available and automatically patched. 2. Security and updates, automatic Kubernetes upgrades, security patching, integrated monitoring and logging. What you manage in AKS: you manage node pools, VM scale sets, pods, deployments, services, application configurations, networking rules, partially via Azure VNet. AKS architecture: Azure Managed Control Plane, API Server et Scheduler, Controller Manager, Customer Node Pools, VMs, Kubelet, Kuba Proxy, Pods. Compute options in AKS: 1. VM scale sets. Default. Managed group of VMs, supports auto-scaling. 2. Azure Container Instances. ACI Serverless Pods. Burst workloads. Key features of AKS: 1. Auto-scaling cluster autoscaler. Node scaling. Horizontal pod autoscaler. Pod scaling. Vertical pod autoscaler. Resource tuning. 2. Networking. Azure VNet integration. Native networking. Azure CNI or Kubernetes load balancer integration. Ingress controller support. NGINX. AGIC. 3. Security. Azure Active Directory AAD integration. Role-based access control. RBAC. Managed identities, private clusters. 4. Observability. Azure Monitor for containers, log analytics, Prometheus integration. AKS versus X versus GKE feature. AKS X GKE provider. Azure, AWS, Google Cloud. Control plane managed setup complexity low very low. Networking. Azure VNet, AWS VPC, GCP VPC. Identity. Azure ADIM. Simple analogy: think of KubeAdmin equals building your own house. AKS equals living in a fully managed apartment in Microsoft Azure ecosystem where plumbing, electricity, and security are handled for you. Use cases: enterprise Azure-based applications, microservices architectures, hybrid cloud deployments, Azure Arc, scalable web applications, CI or CD-driven container workloads. Limitations: Azure vendor lock-in, less control over control plane. Networking can be complex. VNet design. Cost of managed services. Interview-ready definition: AKS, Azure Kubernetes Service, is a managed Kubernetes service provided by Microsoft Azure that automates the deployment, scaling, and maintenance of Kubernetes clusters by managing the control plane, while allowing users to run workloads on Azure managed node pools integrated with Azure services like VNet, AAD, and monitoring tools. Nice. Let's continue. Question 2. What is container runtime? Here's a strong way to approach it. A container runtime is the software responsible for running containers on a host machine in systems like Kubernetes. Core idea: a container runtime is the engine that pulls container images, creates containers, and manages their life cycle. Start, stop, delete. Why it is needed: containers are just images until a runtime downloads the image, creates isolated environment, allocates CPU, memory, network, starts the application process. Without a runtime, containers cannot execute where it fits in Kubernetes. Kubernetes nodes use a runtime to run pods. Kubernetes kubelet container runtime. Containers: the kubelet tells the runtime what to run. Container runtime interface, CRI. Kubernetes uses a standard called CRI, container runtime interface, so it can work with different runtimes. Types of container runtimes: 1. High-level runtimes handle image management plus container lifecycle. Containered CRI. 2. Low-level runtimes actually create containers using Linux kernel features. Runt-cron. Popular runtimes: 1. Containered, most common, lightweight and widely used, originally part of Docker, default in many Kubernetes setups. 2. CRIO, designed specifically for Kubernetes, lightweight alternative to containered. 3. Docker, legacy in Kubernetes, previously used directly nor replaced internally by containered, via Docker shim removed. How it works step by step. 1. Kubelet receives pod spec. 2. Kubelet sends request to container runtime via CRI. 3. Runtime pulls image from registry. 4. Runtime creates container using Linux namespaces plus grubs. 5. Container starts running. Key responsibilities of runtime image pulling from Docker Hub, ECR, etc. Container creation, resource isolation, CPU, memory networking setup with CNI plugins, lifecycle management, start or stop or restart. Simple analogy: think of Kubernetes equals manager, kubelet equals supervisor, container runtime equals worker who actually builds and runs the container. Container runtime versus Kubernetes components. Component role: kubelet node agent. Container runtime runs containers. CNI networking, CSI storage. Why runtime matters: performance of container startup, security, isolation, resource efficiency, compatibility with Kubernetes best practices. Use containered or CRIO in production. Avoid legacy. Docker runtime, keep runtime updated for security patches. Interview ready. Definition: a container runtime is the software component responsible for pulling container images and running containers on a node by managing their life cycle and resource isolation using Linux kernel features, and it is accessed by Kubernetes through the container runtime interface, CRI, to execute pods on worker nodes. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.